Welcome to video lecturing on BSc first semester mathematics on matrices. This is on unit 2 system of linear equations. So in this we are going to study about the 24th session. So in this session we are going to study about some more problems on existence and uniqueness of solution of a non-homogeneous system. It is again the continuation of the previous session. In the previous session we have seen some examples. So this is the continuation of, in this session we are going to study some more examples on the existence and uniqueness of solution of non-homogeneous system of equations. That is the recap of the previous session was again same, existence and uniqueness of solution of non-homogeneous system, and the learning objectives of this session are we have to understand the meaning of non-homogeneous system and existence and uniqueness of solution of non-homogeneous system. That is, we are studying some more examples on the system of non-homogeneous equations. The outcome of this session is again same. We can understand the criterion for existence and uniqueness of the solution of non-homogeneous system of equations. Let us take one more example on this non-homogeneous system of equations. So where in what condition we can have here uniqueness, and that is whether it has a unique solution, finite solution, infinite solution or no solution. Let us take one example. Check for the consistency and solve this equation. X plus 2y plus 3z is equals to 14. 3x plus y plus 2z is equals to 11. 2x plus 3y plus z is equals to 11. First you have to find the augmented matrix. And all of you know augmented matrix is A colon B, which is equals to, first you have to write the coefficients of x, y, z in first equation along with the RHS, that is 1, 2, 3 colon 14. Second equation is 3x plus y plus 2z is equals to 11, and the coefficients are here 3, 1, 2 colon 11, and third row is the coefficients of x, y, z in third equation along with the RHS, so it is 2, 3, 1 colon 11. And we can make these two elements to be 0. For that we have to use this row operation. R2 changes to R2 minus 3R1 here. This is 3 minus 3 times of 1 gives 0. Therefore, you have to use this row operation. R2 changes to R2 minus 3 times of R1. Similarly, to make this element 0, we have to use here, we have to use these two elements. No, it is R3 changes to R3 minus 2 times of R1, because here 2 minus 2 times of 1 gives 0. This is nothing but here, this is R2 minus 2 times of R1. So we will get here this element is equals to 0. So like this only you have to find the remaining elements also. This is R2, here it is R2 and R1. That is, second element is here, R2 is 1 minus 3 times of R1, R1 is 2. 1 minus 6 is equals to minus 5. Similarly, these two elements you have to use. This is R2 is 2 minus 3 times of R1. R1 here is how much? 3 it is. 2 minus 9 is equals to, you will get minus 7. And lastly, this last element, this is 11 minus 3 times of 14. So after simplification you will get here it is equals to minus 31. So similarly we can simplify this third row also. Third row is equals to third row minus 2 times of, you have to use these two rows, and I have explained many times. I hope you can do this one easily. This is R3 minus 2 times of R1. These two elements you have to use, you will get this element, and using these two elements you will get here the second element, and using the remaining also same thing here. You will get third row as 0 minus 1 minus 5 colon minus 17. Then we can interchange R2 and R3, because here so in R2 we have minus 5, first element is minus 5. In R3 the first element was minus 1. So if you interchange these two rows, then this second row starts with minus 1, so that it becomes easy to make the below elements to be 0. So for that we have interchanged R2 and R3. I want to tell you here, so why we have interchanged this one means here, why we have interchanged here means, see here we have minus 1, here we have minus 5. If you interchange it becomes here, first one element become minus 1, so that we can make this minus 5 0 very easily. For that we have interchanged here. So after interchanging, it becomes first row is 1 2 3 colon 14, second row is 0 minus 1 minus 5 colon minus 17, and third row is 0 minus 5 minus 7 colon minus 31. So again we want to make this element 0. For that we have to use the row operation, that is R3 changes to R3 minus 5 times of R2, that is here R3 is minus 5 times of R2 above this element we have here minus 1, that is minus 5 plus 5 becomes 0 here, like this. So similarly next element is also same here, R3 is minus 7 minus 5 times of R2 is minus 5, minus into minus plus 5, 25 minus 7 is 80 will get. Similarly we will get the third element also, same thing here, this using this one we can have here minus 54, this plus 54. What this implies here? This implies the rank of this matrix. Here again we have to write a rank here. Rank of A colon B. So this is the A colon B. Rank of A colon B. How many non-zero rows are in there in this matrix? It is 3. There are 3 non-zero rows. So it is rank of A colon B is 3. And similarly what we have here? This is matrix A. So rank of this matrix is again what here? Here also we have 3 non-zero rows. Therefore rank of this A is equals to 3, and the rank of A colon B is also equals to 3, which is equals to the number of unknowns. So what we can say here, if the ranks are equal and it is equal to number of unknowns, then it has a unique solution. So what we can say here, so in the next slide we can see, this is from this final form of A colon B, you have to write this matrix into equation form. That is, it becomes what here? First equation is x plus 2y plus 3z is equals to 14. So from this first row we will get this equation. And from second row what we get here? From this second row what we get? The equation is minus y minus 5z is equals to minus 17. And from last row what we can get here? 18z is equals to 54. This we can see in the next slide. So like this we will get 3 equations. That is, we got these 3 equations. So from these 3 equations what we can say here? From third equation what we can say here? This implies here z is equals to 54 divided by 18, which gives 3 it is. Z is equals to 3 will get here. Similarly from second equation, what this implies here? Second equation implies what here? Y is equals to take z in this, this is 17, this side becomes 17 minus 5z. Substitute the value of z here. So 17 minus 5 into 3, that is 17 minus 15 is equals to, you will get 2, y is equals to 2 you will get here. Similarly you have to substitute all these values in equation 1. So equation 1 implies what here? X is equals to 14 minus 2y minus 3z, and this implies you have to substitute the values of y and z in this equation. So x is equals to 14 minus 2 into y value here is 2, you have to substitute 2, and minus 3 into z is also 3, substitute here. After simplification you will get what here? This is 14 minus 4 minus 9 it is. So 14 minus 4 is 10, 10 minus 9 it is equals to 1. So you will get here, this is x is equals to 1. Like this you will get the values of x, y, z are x equals to 1, y equals to 2 and z equals to 3 is the required solution of this non-homogeneous system of equation. So this is about the solution, and again I have given you 5 multiple choice questions. You can solve these questions yourself. I have given answer also, and you have to verify your answer with this answer by solving this example. Here you have to the system of equation is, you have to verify whether it is consistent or inconsistent. Consistent means it has a solution, and inconsistent means it has no solution. This you have seen by finding the determinant of this matrix. And you have to find the values of x, y, z which satisfy this equation, so for which it has unique solution. And third one is, you have to find the value of lambda and mu which satisfy these 2 equations which has infinite number of solutions. So it has 3 conditions, whether it has finite solution, infinite solution, that is unique solution, infinite solution, and no solution. You have to use this third condition. If the system has infinite solution, then what will be the values of lambda and mu? This you have to verify. And lastly, and one more example is the condition for which the system is consistent. Again, the consistent means you know the condition for the system to have a consistent, that is you have to verify. So for what condition? So this system is consistent. And lastly, the solution of the system of equation you have to verify. Again, it has unique solution. You have to find the values of x, y, z which satisfy this condition by applying this row operations, that is by finding the rank of this matrix using the condition of unique solution of the system of non-homogeneous equations. This is about this session. In this session we have seen how to solve this system of non-homogeneous equations, and I have given 5 multiple choice questions also, and this is about this session. Thank you very much for watching this. Thank you.